When you peer across the rusted Martian surface through photos, you would be forgiven for thinking that Mars is a place of stillness. Flat, dusty landscapes seem to stretch out in all directions, with nothing but scatterings of rock and the faint whistling of the wind to keep at bay the almost oppressive solitude. But stay a while on this red world, and you will soon see a towering wall of dust and sand brewing on the horizon. You might think to yourself that this dust storm is similar to those we see on Earth, and have no idea that this storm is about to grow so large its thick dust will swallow up not just a region, not just a continent, but the entire planet. This all-enveloping superstorm arises on Mars usually every 3 Martian years, or about 5.5 Earth years. Its choking dust will blot out light for weeks, even months, and represents a huge challenge to the continued functionality of any technology that we put up there. If humans ever want to settle down on the red planet, it will be a hurdle we have to overcome. Which is a problem, as there is much about the origins of these storms that we still don't know. I'm Alex McColgan, and you're watching Astrum. Join with me today as we explore what we do know about the characteristics, mechanisms, and impacts of the Martian super dust storms, and what any humans would need to be aware of to make it through one. Mars didn't used to have to deal with planet-sized dust storms. Although Mars is now a barren, arid planet, it once had a thick atmosphere that was warm enough to support the existence of running water. However, over the course of the billions of years of Mars's existence, Mars dried out, and its atmosphere bled away until atmospheric volume was at less than 1% of what we have here on Earth. Those dust storms didn't just start happening because Mars became dry though. Although we don't understand everything about such storms' origins, we assume that a key component is Mars's temperature. With less atmosphere, in spite of Mars's high CO2 levels, Mars became far worse at retaining heat. When the surface starts to cool, there is no air to catch the escaping warmth. It is at the point where, if you were to stand on the planet's equator during its warmest time of the day, your feet might feel 23 degrees Celsius, while at your head, it would be 0 degrees Celsius. This means between day and night, Mars has some intense temperature swings. Temperatures there now range from highs of around 27 degrees Celsius down to a freezing minus 133 degrees Celsius at night. Temperature differences can cause winds to form, which can bring different weather systems across the planet. However, Mars's arid weather is no longer driven by rain and water cycles, but cycles of dust. Dust plays a surprisingly crucial role on Mars, and without it, those planet-spanning storms would likely never form. The atmosphere might be too thin to capture and transport heat, but the Martian dust, now that's another story. It all begins with that Martian dust getting into the air. There are a few mechanisms that make this happen. One is dust devils, of which Mars experiences thousands every year, usually during the Martian spring and summer. Warm rays from the sun heat the ground, causing the air directly next to it to rise, and cool air from the atmosphere to be drawn down to fill the vacuum. These contrasting winds create rising spirals of air that can end up hundreds of meters wide and 8.5 kilometers tall, although many are much smaller. Regardless of their size, as they meander their way across Mars's all-encompassing deserts, they suck up dust and hurl it up into the atmosphere, creating a haze of slightly darkened skies in their wake. This process is thought to contribute to a miasma of background dust that constantly lingers in Mars's atmosphere. While this is the flashiest way by which dust gets into the atmosphere, it's not the most prevalent. Far more common is the simple influence of wind moving across Mars's dusty surface, and a process known as saltation. Mars's dust is surprisingly difficult to get up into the air. Small particles have a lot of cohesion due to being slightly electrostatic, kind of like packing peanuts, so that they stick together. which means they need a certain amount of momentum to get them going. Oddly enough, larger particles are actually easier for the wind to get moving as they experience less cohesion. So it's these larger sand grains that are lifted by gusts of wind and are moved for short distances. But because they are ultimately too heavy for the wind to suspend, they crash down again, and the force of these tiny impacts imparts enough momentum to overcome cohesion and get the lighter dust airborne. However, once it gets up there, Mars's lower gravity means that it's easy for dust to remain in Mars's atmosphere for a really long time, weeks or months. And this is enough to start driving the formation of storms. Because, unlike the thin air around them, particles of dust are really good at collecting heat from the sun. As the sun warms dust in the atmosphere, they act like little radiators, slowly releasing the gathered heat into the air around them where previously the warmth would have passed through the ground below. This makes the atmosphere nearby much warmer. Warm air rises, but now it begins doing so on a much larger scale than when forming the dust devils earlier. Wind has to be drawn in from the sides of the rising air mass, but this only adds more fuel to the fire. More wind means more saltation, and more dust being thrown into the atmosphere, and more opportunity for the atmosphere to warm. Eventually, this out of control process ramps up into a regional dust storm. The good news is that on a local scale, a dust storm on Mars is not very dangerous in and of itself. Wind speeds top out at 97 kilometers an hour, only half the speed of hurricane winds on Earth. And even this is misleading due to the thinness of the atmosphere. Even when it is traveling quickly, you wouldn't feel much. In the same way, a single person has less pushing power than a whole crowd. Despite what you might see in some science fiction stories based on Mars, dust storms are not powerful enough to push over spacecraft or break satellite dishes. However, such storms carry their own incidental dangers. It's very bad news for any Martian rover that relies on solar power to function if a dust storm filled with slightly sticky electrostatic dust particles suddenly passes overhead. Gradually, dust deposited from such storms is enough to block sunlight from reaching a rover's solar panels, which has spelled the end of more than one mission from Earth. But the problems magnify when you start scaling such storms to larger and larger sizes. Mars does not have a perfectly circular orbit. Every year, around the Martian southern hemisphere's spring and summer, the planet is at its closest to the Sun and, as a whole, is warmest. For reasons we don't fully understand, during this time of year, regional dust storms start merging into a superstorm the size of a continent. It's of course possible that several storms just happened to be forming anyway and they started to merge just by proximity. Although their regularity makes it seem like coincidence is insufficient an explanation. After all, these happen yearly, like clockwork, once the temperature gets warm enough. Those are just the continent-sized ones. Scientists of yet do not have an explanation for the stage above that, the planet-sized storms. These occur once every 3 Martian years, which seems like a short enough timescale that you can rule out Milankovitch cycles as their origin. Those normally work on timescales of thousands to hundreds of thousands of years. Perhaps there is some aspect to the dust cycle that needs to restock, and it takes 3 Martian years, or around 5.5 Earth ones, to do so. We don't really know. While most dust storms on Mars last only a few days, these apex of storms can last for weeks. The impact of these storms can be profound for any human technology around the planet. Scientists can measure the availability of sunlight on Mars using aerosol optical depth, or AOD, to check how much sunlight is being absorbed or reflected by pollutants in the air. The AOD on Mars is usually around 0.5. For context, an AOD of less than 2 is needed before rovers like Opportunity or landers like InSight can charge their onboard batteries. The thick smoke caused by a wildfire on Earth that starts to turn day into night is an AOD of 7. These planet-sized dust storms hit AOD of 9 to 11. They represent a near total blockage of light. In 2018, a storm of this variety killed the Opportunity rover by swamping its solar panels and forcing it into hibernation mode. Without power running through its onboard heaters, the wildly oscillating day-night temperatures caused something critical to break in the rover, and it never woke up. These storms are a problem for other rovers too, even ones with onboard nuclear batteries like Curiosity. The clouds are thick enough to block communication to and from the surface, meaning scientists have little choice but to wait them out. But that's not all. Even satellites can be affected by these storms. The colossal amounts of warming dust in the air causes the entire atmosphere to expand, bringing some of it into the orbital paths of satellites. They have to burn precious fuel, making course corrections to ensure the atmospheric drag doesn't bring them crashing down out of the Martian sky. If you were a human hoping to settle on Mars, you'd need to find a way to overcome these issues. Solar-powered settlements would not survive such storms without another source of power, and humans don't do well at such freezing temperatures. Losing the ability to contact our satellites could also leave us isolated and vulnerable for those few weeks. People would need to have a certain degree of self-sufficiency, as if anything were to go wrong while a storm was blowing, you wouldn't be able to call for help. Still, in time, these storms prove to be their own destruction. Blocking so much light eventually means that the surface stops getting warmed enough to create the upswelling winds that lifts the dust into the air in the first place. Without more rising dust, these storms starve themselves and peter out. Quiet returns to the red planet. Things are still once more. Any rovers that survived can emerge from hibernation mode, ready to continue with their science now that communications with Earth have resumed. As of 2023, there are 3 rovers active on Mars: NASA's Curiosity and Perseverance, and China's Zhurong. Of the 3, Zhurong is the only one utilizing solar panels as a power source. It will have to be careful. The last superstorm was in 2018. Given that these occur on average every 5.5 years, the next one could be coming soon. A little wind will start blowing, some dust will start to stir, and the cycle will begin anew. Preserving the beauty of space is something I am passionate about. I love the planets and moons of our solar system. Each has a distinct personality and houses incredible vistas. Do you have a favorite? Let me know in the comments what your favorite is. Mine is Earth, and I have captured its awe-inspiring beauty and hung it on my wall with my display collection. I've made designs for these unique metal posters in 2 different styles for 11 different objects in our solar system, and I really love how each of them has turned out. You can see zoomed in planet horizons or full planetary disks and their accompanying moons, all based on real imagery where it was available. Maybe you will love it and want it for your home, but equally it can be a great gift for someone who loves space. If you're interested in supporting the channel and owning an Astrum display, then follow the link in the description below for a 20% discount on your next purchase. Go check it out. Thanks for watching, and thanks to my patrons and members for your support. If you want to support too, check the links in the description below. All the best, and see you next time.